Hello, my good friends out there. I remain Dr. D.I. June, your lecturer on chemistry on social media. Today, we shall be discussing on the topic I titled the oxidation number of an element in a chemical formula. The oxidation number of an element in a chemical formula. This is also a very vital area of chemistry. It's a fundamental that students using chemistry should be aware of. So please, hereafter, you comment, like it, and also follow me. You can click on my bio and access my link. So let's go by what I have here. By layman definition, oxidation number is the combining power of an element or an ion or a radical. It is the electrical charge that the element or the ion appears to have as determined by a set of arbitrary rules. These rules are: 1. The oxidation number of all elements in the free state, that is, uncombined with any other element, is 0. This can be shown as a 0 written as a superscript to the right of its symbol. Examples on the board here. We have sodium, you are seeing 0 here. Magnesium, you are seeing the 0 here. Chlorine, you are seeing the 0 here. Phosphorus, you are seeing the 0 on top as a superscript. Now, but these zeros normally are omitted. If you see them in textbooks, you don't see the 0 there, but that's how it's supposed to be. Number 2 arbitrary rule is that the oxidation number of a single element has the same size and sign as the charge of the ion. For example, the oxidation number of sodium, magnesium, aluminium, chlorine, and sulfur are +1, +2, +3, -1, and -2 respectively. See them here. Sodium, magnesium, aluminium, chlorine, and sulfur. You can see the charges on top of the ions. So this is sodium is +1, magnesium +2, aluminium +3, chlorine -1, and sulfur -2 respectively. All right, let's continue. Note that the negative or the positive sign for the oxidation number always comes before the number. Look at it here. The minus, which is the sign, comes before the 2, or the plus comes before the 3. That's what we're talking about. All right. Likewise, the oxidation number of some radicals or some ions, such as trioctonitrate 5, tetraoxosulfate 6, tetraoxophosphate 5, tetraoxomanganate 7, and ammonium ion are -1, -2, -3, -1, and +1 respectively on the board here. Nitrate, sulfate, phosphate, manganate. This is ammonium, -1, -2, -3, -1, and +1 respectively. Okay, now let us take this following, also very important. In most compounds, the oxidation number of oxygen is always -2, except in peroxides, where its oxidation number is -1, while that of hydrogen is always +1, except in hydrides, where its oxidation number becomes -1. So, oxidation number is usually abbreviated as ON. As ON. ON. If you say ON, it means oxidation number. Now, oxidation number has a formula. Look at it here. The algebraic sum of the oxidation numbers of all the elements in a chemical formula is 0. ON formula equation is equal to the algebraic sum of the oxidation numbers of all the elements in a chemical formula is equal to 0. It's from this formula you can determine the ON of a particular substance or a particular element in a given compound. If, for example, now this is called disodium tetraoxosulfate 6. 3 elements are here: sodium, sulfur, oxygen. Sulfate 6. That means sulfur combining power here is 6. That's what it means. And it will calculate to get that 6 as time progresses. Using the above formula equation, it is possible to calculate the ON of any given element in an ion or in the chemical formula as long as those of the other elements are known. So, by the time we go into calculations of these ordinal numbers, this formula will come into play and you will understand it better. So, please like it. Follow me on my YouTube channel. Thank you.